All right. So we've already seen this equation. The only difference is, look, y is equal to a, the initial amount, okay? B, up here when we're graphing these, that's just our multiplier. So what the multiplier is saying is the 1 plus or minus the r, that's just our multiplier, right? So the multiplier is just established as one number after they've combined all that, okay? So this isn't different. The b is just our multiplier. X is our time, as we had before. And this plus c is this new thing that we're introducing. It's called an asymptote. Or sorry, asymptote. Oh, nice one. Wow, that's good, Axel. This plus c is our asymptote, and that's kind of like the limit, okay? So you could think of if you were flying an airplane, you wanted to get as low to the ground as you could. Maybe you'd come down, you come down, you come down, you come down, and then you wouldn't hit the bottom edge. You would just go right next to it, because that's how you can get closest to the ground, right? An asymptote is kind of like the ground, okay? If you're flying a plane and you're just wanting to barely get close to the ground, the asymptote is the ground. So you don't want to hit it. You want to be like right there and then just keep going closer and closer forever. So this c is the new thing. That's really the only new thing, okay? Now, I know there's going to be some confusion here, because if I look at this, really in your head, try to separate what we did with linear equations, right? Linear equations and exponential equations. Because if you separate them, then you won't get confused that our b value in this case is our multiplier, our a value is our initial amount, which is our y-intercept. With the linear equations, the lines, the difference was that it was y equals mx plus b, and that b value was by itself, it was the constant. So just kind of reconfigure your brain here that with exponentials, you have to really plug these values in and take them for what they are, okay? This b will function differently than the b within the linear equation. Just kind of separate in your head that this is exponentials. It's kind of like a different country, right? It's just everything's a little bit different. All right. So if we look at our graph here, we see that we have this asymptote. That's like the ground. You know, the plane is coming down. It never touches the asymptote. It keeps going closer and closer and closer, but never touches it. And that is, our asymptote is our c value. Okay, that's our c value. Now, this point right here, I want to go ahead and, actually, I don't know if I can do that on Desmos. I wanted to. Yeah, I'm going to do it anyway. Okay, so I'm going to share right now Desmos. And with this, it won't be on the video, but it will have enough info, I think. I think this is the one I want. Yes. Right there. All right. You guys can see this? All right. Maybe you can't see it if you are at home. Sorry about that. But you see, I have it all set up here. I have it all set up here. Now watch. I'm gonna put the c value. You see the c value right here? That's our asymptote. Watch what happens when I move it up. Now it's at 1. You see how it goes right next to 1? It keeps going up. As I make the c value larger, I can bring it all the way up to 5. And you can see that it gets close to 5, but it never quite touches it. If you really zoomed in right here, you would see it never touches it, okay? That's how an exponential works. Now watch, I'm gonna put it back down at like at 0. So when it's at 0, notice where the asymptote is. Where's the asymptote? Right there at 0, because c is 0 in that case. If I were to move it down, you see, then we'd end up with an asymptote that was negative. So the c value is just telling us where the asymptote is. Oh, I wonder if I could do this. Let's see if I can do this. This would be awesome. This might actually allow me to do it. Okay, so now we have a situation where our a value, let's say we started with 1, right? Where is the y-intercept? Right here. And the reason why the y-intercept is right here, right, is because right now, look at this right here. If this x value is 0, okay? If the x value is 0, then we're at x is equal to 0. When x is equal to 0 here, any value raised to the 0 power is equal to 1. Any value, any base raised to the 0 power is equal to 1. So a times 1 is the value for A. That's the explanation on why that works. If you just want to memorize, hey, this initial value is always our y-intercept, that's fine as well. Okay. Now you may look at this and say, well, I'm not sure what to do next. This is where when we graph it, we're going to use a table. So this explanation is a little strange because I'm using the doc cam and trying to show it. So I'm just going to go back to the doc cam and do some examples, okay? But maybe I'll even link this Desmos graph. How about that? I'll link it, exponential practice. So you can play around with the sliders, and I'll share that in the homework. All right, let's go back to this. Hello. So now we kind of played around a little with Desmos. It wasn't the greatest, but it helps us at least see where we're coming from here. So now look, if I'm looking at this, and I'm even going to use one of the graphing paper in the back of your book. So if you haven't yet, go ahead and access, a page of that. And let's just do a few examples. Excuse me. All right, how about if we have this? Y is equal to 2 times 3 raised to the x minus 1. Okay. So the first step is to see, okay, where is well, let's plot the y-intercept, and we don't even have anything written here. So with exponentials, they're always going to go to the right. So I generally make my graph, with x and y. Here's my origin right there. So the graphs are going to be over here for now. Okay. So let's see. Where's my y-intercept? My y-intercept is always the initial value. So on your graph, go ahead and plot your y-intercept. What is your y-intercept? If you don't remember, let's look up here. Where do we find that y-intercept? It's that initial amount. So I look here. Remember, the y-intercept is where this graph is going to cross the y-axis. Good. 2. Very good. It's right here at 2. 1, 2, 3, and so on. Okay. So I know it's going to cross right there. Now, when I look at this, the next step is to sketch the asymptote. Where do I find the asymptote? So I know this is my y-intercept. It's my A value. Now, the asymptote was our C value. Let's look at that. This is our asymptote. You can just write it like that, asym, A-S-Y-M. All right, so the asymptote is at -1. So really, asymptotes are always going to be horizontal lines, and we'll go here at -1 and put a dash line. Asymptotes, I want you to do dash. Okay, this is our asymptote, and it's equal to y is equal to -1. Y is equal to -1. Okay. Now, the next step, now we're going to plug in 3 values into the table and find our other points. So this is where you can make a really quick table, and my suggestion is to use 1, 2, 3. Let's just see what happens with some easy numbers. All right. So this is where you're going to just have a little bit of work to do as far as plugging in some numbers. Let's do them right here. I'm just going to rewrite them with that number plugged in, and then it's all PEMDAS. Okay. So what did I do? For my x value, I plugged in 1. So you plug in 1 right here, right? And now it's just PEMDAS. Now it's just PEMDAS. So once you're doing this, you're going to plug in for these values. Here's 1. And now it's just PEMDAS. So I look at that, and in the parentheses, there's nothing to do. The exponent, sure, let's rewrite it with the exponent simplified here. 3 to the first power is 3. All right, let's see. Is there any multiplication? Yeah, right here. So let's do that step. 2 times 3 is 6. So we get y is equal to 5. So when I plug in 1 for x, I get 5 for y. Now what we've created here is an ordered pair, 1, 5. If you get confused what comes first, it's always alphabetical. Everything in math is alphabetical, x, y. So let's find the point 1, 5. 1 for x, 5 for y. Wait, that's 3, 4, 5. 4, 5. So 1 for x, 5 for y. And that is our next point. Okay. Now let's see. We have a 2 here. Let's plug in 2. I'm just going to use this space. Y is equal to 2 times 3. Remember, x is right here. X is the exponent, so I'm going to plug in 2 right there, minus 1. Okay. Same steps. Apply the exponent. 3 squared is 9, minus 1. Two times 9 is 18, minus 1. Y is 17. So what I figured out is when I plug in 2 for x, I get 17 for y. So now we got to plot this point, and we'll see if we can draw a graph from that. You need at least 3 points, but let's see where this ends up. 5, 6, 7. Let's do it how I should do it. So this is the ordered pair 2, 17. So 2 for x, 17 for y. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Right here. And if you plug in 3 points like this, that's fine. We can use the first point here. So watch, I'm going to just go ahead and I do the left side of the graph. And then I do the right side, making sure that it goes down towards that asymptote, but never touches it. Okay, that's my graph. So actually, I see I should have moved this over. You'll find where it should fit. Probably should put my graph more like this. More like that. Okay, so it was too close to the corner. I want to do just a couple more here. Specifically, are there any questions that are coming up? How would you graph an equation without an asymptote? So that's a good one. Let's do one here. It's going to be quicker. What if there's no asymptote? There actually is always an asymptote. Okay. For instance, this one doesn't have a numerical value for the asymptote, right? But what is our C value here? Let's bring back this. What is our C value in this case? Yeah, Jessica, you got it. The C value is 0. So even if there's no C value, good, Ahmed, you got it. Just in case there is no C value listed, there still is a C value. Our asymptote is going to be at 0. So let's go ahead and just put it graph a little better and towards the middle more. So I look here, same process, plot your y-intercept. The y-intercept is always our initial amount. Y-intercept, that's our A value. 4. 1, 2, 3, 4. So first step, plot your y-intercept. I did that here. 4 is my A value, and that's always my y-intercept. Now we need to do the asymptote. Sketch the asymptote. It's at 0. So just there at y is equal to 0, it was right on top of that x-axis. This is y is equal to 0, and that's our asymptote. Okay, and now let's just do a little bit of plug and chugging. So let's do, we already did 0, let's do 1 and 2. 0 was 0, 4. 0 for x, 4 for y. That is our y-intercept. Anytime x is equal to 0, you're finding your y-intercept. Now let's plug in 1. Let's do that. Y is equal to 4 times 2 to the first. Y is equal to 4 times 2. Y is equal to 8. So we got to go 1 over. 1, 2, 3, 4, 5, 6, 7, 8. Let's do it for 2, and then I think we'll be close to wrapping this up. Let's see. 4 times 2 raised to the second. Nice. Jessica, you're on top of this. It's perfect. Oh, you even did 3. Perfect. So we get 4. 2 squared is 4. So in this case, y is 16. When we plug in 2 for x, we get 16. So that's 2. And this was up to 8. So I go over 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Ooh, just barely. All right. So I like to turn the paper around so I can get a nice curve that's natural to how I write. And then I know it's going to go down, but never touch it. All right. Give it a really honest answer here. Thumbs up, sideways, down for this process. How do we feel? Thanks for the thumbs up, sideways, down. No worries. Okay, and I really want to know. Is there something that's specific? Let me go through the steps and give me a thumbs up if that step's good. A thumb sideways if that step's hard. The thumbs down is I don't understand that step. Okay, so if your video's on, you're getting more feedback right now. Okay, so what we did here, let's see. We have to, well, I guess we can even say before we plot the y-intercept, we have to identify the parts of the equation. So thumbs up, sideways down for identifying the different parts of the equation. That could be just memorizing what goes where and what is what. Okay. How about the actual graph work, like navigating around the graph, remembering that, to the x, to the right is positive, up is positive, down is negative. Navigating the graph. Okay, good. How about step 1 was plotting the y-intercept? Plotting the y-intercept. And it might just be like, yeah, I missed that day. No worries. Okay. Looks like everyone has that. Sketching the asymptote and just about the asymptote. Is that tricky or new or, no? Okay. Okay, how about plugging in 3 values and doing the algebra to find your y values? Plugging in the values. How's that? Plugging in the values? Yeah. Okay. The last step is to use the answers from the values to plug in points. How's that? Plugging in the points to make our graph? Okay. A couple key things I'll remind you is remember that an ordered pair is always x, y. And I kind of like teaching it this way. You ever been to one of those, arcades where they have, this box, and inside there's all these little monos, like, there's like a little teddy bear, there's football, right? There's a watch for some reason, or there's, different things, right? Lots of legs. You guys know what that is. That's old school, right? And there's the little like hole here, and what you're doing is you have that little grappling hook thing, and you're lowering it down to try to pick up. You guys seen these before, right? You've seen it before. Okay, so remember, if I wanted to go for this item, right, I have to go over and then up to be right above it, right? I want you to think about x and y similarly. X is just how far over you have to go. Y is just how far up and down you got to go. Okay? It's always X, Y, just like alphabet. X, Y, Z, A, B, C. It's always in alphabetical order. So when I'm plotting these points, if I just wanted to plot 2, 1, I go over 2 for X. I go up 1 for Y. And I get this point right here at 2, 1. Okay? We're going to have more practice with this. If that's still claw machine, that's what it's called. Thank you. So if you're having trouble with this part, like graphing and being familiar with the graph, you got to come in you got to email me and request a time to meet between that 9 and 9:30. Tuesday through Friday, I can do that. And I will be able to shore all that up. If you feel like I'd probably be good to go to a session and figure that stuff up with graphing, then you got to email me, okay? All right. How about one more and we'll call it a day? One more, we'll call it a day. All right, here we go. Good focus, guys. Almost lunchtime. Let's do this one. y is equal to 3 times, let's do 5, raise the x, and let's do plus 2. Okay, so first step is, no worries if it gets a little jumbled. First step is to look at your standard formula here for exponentials and figure out what does each of these values, what does it represent? You see this pattern? You see the pattern? Y is equal to some value in parentheses, an exponent, plus or minus some c. You see how they're kind of aligned? It's helpful if you look at it as like almost like a spatial awareness, where things are located, where the symbols are located. Okay, so I'll go ahead and point out that our a value is our initial amount, always our y-intercept. This is our y-intercept. Okay, this over here is our asymptote. All right. Nice. All right, Jessica, you're on top of it. Good job. All right, so let's go ahead and do what we know how to do, or that we're learning here. And let's first plot the y-intercept. All right, so I need to make my graph, make sure like it's +2. I'm gonna go ahead and do it something like that. All right, last problem. Let's stay focused. Whoops, x, y. So I need to go ahead and plot my y-intercept. So I'm going to go ahead and do the y-intercept is 3. So watch. 1, 2, 3. Y-intercept, always on the y-axis. Always on the y-axis. Then we got to do what? Sketch the asymptote. +2. Okay, so I look, the asymptote is +2. It's always horizontal. Until way later on in math. Okay, Jordan, I'll answer that in 1 second. Next, we got to just plug in some values. So let's do x and y. Let's plug in, we did 0, we got 3. So when you plug in 0 for x, you're at 3. 1 and 2. Let's do it here. 3 times 5 to the first plus 2. All right, let's see. Shortcut, 5 to the first, 5 times 3, 15, plus 2, 17. Let's sketch them all after we do this last bit. Y is equal to 3 times 5 squared plus 2. Okay, 5 squared, 25, times 3, 75, plus 2, 77. So I'm going to run out of space really quick, right? Because I don't have 77. The one thing you can do, no, I'll hold that off. Math 2, you'll learn a little trick for this, but not quite yet. All right, so let's plot this point. 1 for x, 17 for y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, that's really increasing quick. The next one is 277. 277 is going to be way up here, right? So I'm just going to assume it's going to be really close to being like vertical. And that's probably the best I can pull off for this one. I would need to use Desmos for that. All right, I have one comment coming up that numbers 3 and 4 are the same. And actually, let me pause this recording real quick. There we go. I'm going to stop it. All right.